Hi everybody. In this lecture we're going to show you how you can do elementary conversion from base 10 to base 2 using a thing called repeated division. We'll start with some simple examples. Here is 6 in base 10, and we would like to convert it to something else. Let's see, base 2. Well, what symbols would we use in order to arrive at a base 2 answer? Well, one thing we can do is repeated division. Take the number 6, divide it by 2. You get the answer 3 with 0 left over because it's even. Take 3, divide it by 2. 2 goes into 3 once with 1 left over. Take 2, divide it into 1. It goes in 0 times with 1 left over, and now you're done. Take the symbols which resulted, 1, 1, 0, and write them from bottom to top. 1, 1, 0. Surround them with braces and write the base 2, and that's your answer. 1, 1, 0 is equal to 6 in base 10. We can prove this to ourselves using positional notation. It's 1 times 2 to the 0, 1, 2 plus 1 times 2 to the 0, 1 plus 0 times 2 to the 0. 1 times 2 to the 2 to the 2 is 4, so that's 1 times 4 plus 1 times 2 to the 1, which is 1 times 2 plus 0. And this is equal to 4 plus 2, which is equal to 6, which is what we wanted. Now you could say, but this was trivial, and certainly that is true. However, you can do this with much larger numbers. I always like to start with a simple first example. Let's try it again, only this time we'll use a different number. Let's try a number like, pick a number, 17, a nice prime number. We'll take 17, base 10, and convert it into something represented by base 2. So let's start off by saying 2 times 8 is 16, with 1 left over. Then we have 4 with 0 left over. We have 2 with 0 left over. Then we have 1 with 0 left over, and finally there's a 1. So now let's take a look. We write 1, 0, 0, 0, 1 in base 2. Now let's prove it to ourselves. We have 1 times 2 to the 0, 1, 2, 3, 4 plus 1 times 2 to the 0. 2 to the 4 is 16. 16 plus 1 is 17. And sure enough. So we can see an arbitrarily large decimal number can be converted into a binary number. Using positional notation, we can convert from the binary number back to the decimal number. So what we do is we can say from base equal 10 to base equal 2. We use repeated division. And to go back in the other direction, we use positional notation. How's that grab you?